Sup, freaks? It's your boy Marty here to introduce this episode of Tales from the Crypt. Matt Odell and I sat down with the CTO from CommerceBlock, Tom Trevethan, to talk about Mercury Wallet, the software they're building to implement Statechains so that we can get another second layer scaling solution and privacy solution built on top of Bitcoin. It's a very interesting episode. If you guys are interested in Statechains, I highly recommend you pay attention to this one. We dive in, talk about the trade-offs, the security benefits, the privacy benefits, everything that's going on. I'm really excited to see Statechains in the wild, and I think Tom does an incredible job of explaining them, and I'm very happy that him and the team at CommerceBlock are building out Mercury Wallet so that we can get them to market. This episode of Tales from the Crypt was brought to you by our good friends at the motherfucking Cash App. You freaks already know all about them, but if you don't know about them, if you already know about them, then you shouldn't not know about them. But if any of you are out there and you don't know about them, Cash App's helping you stack sats, send sats, sell sats, receive sats. And you can make sats to standard. We're saying sats, 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 because we're no longer buying fractions of Bitcoin. We're buying whole sats. Tens of sats, hundreds of sats, thousands of sats, tens of thousands, millions, tens of millions, hundreds of millions if you're balling out. You can make sats to standard. You could DCA into sats too. If you want to buy daily, weekly, or bi-weekly, you can set it and forget it. We got to figure out when we need to front run Matt Odell. He admitted it last night in a rabbit hole recap that he changed his daily buy. So we need freaks to get out there and start their daily buys at random hours just so we have confidence that at least one of you is front running Matt Odell. On top of the sat stacking, stack slivers of stonks, if you're into the stonk market, you can invest in stonks, okay? I know all of you aren't into the stonks. You're not big stonk fans. The option's there, right? If your favorite stonk's a little too expensive, you can buy as little as $1 via the Cash App. Because all this is connected to your bank account. There's no 4 to 5 day waiting periods. Cash App may even be your bank account. They're offering account number and routing numbers so that you can direct deposit your paychecks into the Cash App. Bank of the future. Check it out. Use the code STACKINGSATS when you do. It's STACKINGSATS. You're going to get $10. And $10 is going to go to our good friends at Owls Lacrosse. That's Owls Lacrosse. Woo! 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 Enjoy this rip. I learned a lot. I hope you do too. Okay.
You've had a dynamic where money's become freer than free.
If you talk about a Fed just gone nuts, all the central banks going nuts.
So it's all acting like safe haven.
I believe that in a world where central bankers are tripping over themselves to devalue their currency, Bitcoin wins. In the world of fiat currencies, Bitcoin is the victor.
I mean, that's part of the bull case for Bitcoin.
If you're not paying attention, you probably should be.
What is up, freaks? Welcome back to Tales from the Crypt. It's your boy Marty Bent here. First podcast recording in my my 3-week getaway from the United States in the islands. I've got a new studio here. I think it's much better than the one I have been recording out of. But Matt and I are very excited for this conversation. We're sitting down with Tom. God, we were going over your last name, Trevethan. Trevethan from CommerceBlock, the CTO of CommerceBlock, a company that launched the Mercury Wallet on Bitcoin's testnet a couple of weeks ago. We wrote about it. It's an implementation of Statechains, which is a second layer solution that we have been writing about and talking about, but wondering whether or not it would ever get implemented. So it seems like Mercury Wallet has launched an implementation of Statechains, and we're just excited to learn about it and to talk with you, Tom, to learn about why you guys built this, to learn about Statechains in general. So I think to start, just learn a little bit about you and what you do at CommerceBlock. I guess how did you find yourself in this position, particularly working on Statechains?
So my background is I was like a physicist. I worked at university doing research mainly in kind of theory and computation, so computational modeling. And then a few years ago, I made a decision to kind of leave academia, and haven't looked back since then. I'm kind of enjoying startup life, which I think is more exciting, more kind of dynamic. So I joined CommerceBlock, must be about 2.5 years ago, and they were just starting out. And at CommerceBlock, we've essentially what we were previously doing was creating kind of blockchain solutions for clients who wanted to tokenize things. So we had this big client called DGLD. They wanted to tokenize gold, so we created a platform for them to do this based on elements, which Liquid is based on, so they wanted their own, they wanted to have permission control over this. So they wanted like KYC integration and stuff, and so we forked elements and created basically a platform for them to use to tokenize this gold. And the idea was that this is all backed up by Bitcoin's immutability and proof of work. So we developed this protocol to basically utilize Bitcoin's immutability, which goes a bit beyond just simple timestamping. That uses this kind of idea, Peter Todd's, of like a single-use seal, so that you can prove uniqueness of this secondary chain. So it's basically an asset-backed sidechain. And so this is what we've been working on for the past, kind of couple of years. But we've struggled really to get kind of traction. Our big argument is this is a great way to scale. And the whole idea of issuing tokens on Ethereum is there's huge scalability problems, and that if you wanted to verify the ownership of something, verify the ownership of the token on Ethereum, you have to verify the whole Ethereum blockchain, which is growing bigger and bigger all the time. So basically, this our motivation for this kind of approach was a scalability one, but really we've struggled to find traction, I think. And issues with integration, exchange integrations, and competing against the kind of big players, EOS and all these people that are essentially funding people to use their platforms. Right. So we kind of on from this, we did get interest from a few people doing privacy-based side chains, kind of separate from Liquid. That would be
excuse me, Matt, there's something going on with your computer or something. It's like putting in this loud noise. I think it's going to mess up the audio.
Is it really? Is it coming from my side?
Yeah, it's definitely coming from you. It happens on RHR too, but since you record the audio, it doesn't mess that up. I think it would mess this up though. You just mute while you're not talking. Yeah. There we go. Perfect. Sorry, Tom.
No worries. So essentially we've kind of started to, we got some interest in doing privacy-based sidechains, but then the real kind of thing that kind of pivoted us is that we got interest from someone to work with us to develop a discrete log contract based system. And one of they wanted to provide some kind of derivative based platform, and we suggested discrete log contracts on Bitcoin. But one of the big problems that we have with discrete log contracts, I guess you're familiar with the idea of DLCs and mm-hmm. how they work, that you have basically a kind of blinded oracle which provides a signature which can be used to settle this contract one way or the other. But the real big problem with DLCs was the problem of like capital lockup. So obviously, if you enter a DLC with someone and it's supposed to mature at a certain date, say with some oracle providing some price, your capital is locked up in that contract for that time. And so one of the things we'd been aware of this state chain idea from Ruben Samsung, kind of last year. And we thought this would be a really great way of being able to actually change the ownership of one position of a discrete log contract without having to do any on-chain transaction. So this was our original motivation for looking at this, was that we wanted to have a system where we could enable, say, discrete log contracts to be freely traded, or the positions to be freely traded, without having to necessarily do an on-chain transaction. So that kind of sparked our interest in it. And then I guess when we started to think about actually how we were going to implement this, it grew from there, and we're thinking basically all the advantages that this gives us in terms of privacy. And privacy seems to be a kind of quite profitable kind of business at the moment. And we looked at the market and seeing that, we've seen privacy wallets and privacy, Wasabi, Samurai, having creating quite a lot of mind share and also earning quite a lot of money. So this seemed to be an interesting way to pivot, and also from a kind of a personal point of view, it's more interesting working on Bitcoin. And everyone loves. That's what everyone really wants to do is do Bitcoin things. We got excited about this, and we're going ahead and creating an implementation. We much finished the kind of back end of this. Now we're kind of working on a wallet which can use this.
Yes, it's incredible. Actually, using Statechains as a solution to solve the capital lockup at DLCs is extremely novel. It makes a lot of sense because you can just trade out of that position if you want to, again, without touching the chain, without actually having to make an on-chain transaction. You just pass that along. So I think using that as an example is probably a good jumping in point to explain Statechains, how they maybe compare to something like a Lightning Network as a second layer solution. What are the differences? What are the trade-offs? And how and why you think they're important?
Okay, yeah. So really, I guess getting down to the simplest kind of explanation or analogy. I mean, it comes down to what's the simplest way you could do an off-chain transfer of ownership of, say, in the first instance, just say a Bitcoin UTXO. And the very naive thing you could say is, well, just give someone the private key, which could work, but it's not secure because the previous owner obviously, has to be trusted to delete their private key and not use it to then steal the output. So, I mean, no one would ever trust someone just, giving them a private key to a Bitcoin output.
Unless you hold a ballet wallet.
Yeah, of course, yeah, and well, well, this is the kind of a good way of looking at it. It's like a virtual open dime. So that's the kind of, obviously open dime solved it with kind of trusted hardware where you trust the stick they've produced and that it's not been tampered with, and that therefore the key is no one can know the key. So essentially the basic idea of Statechains is that you basically, so you're basically passing around ownership of a single UTXO. And that's the first important thing to understand about it, which is a disadvantage, is that you can only transfer whole UTXOs. So comparing that to obviously, say, a federated sidechain where you peg in a certain amount of Bitcoin and then you can trade it around with whoever you want and then peg out an arbitrary amount. In a state chain, you essentially you're locking up a fixed amount which you can then pass around, and then you withdraw that exact same UTXO. So the way, I guess, the way in which it works really is that you have a trusted entity. So this it's clear. I guess it's good to be clear from the outset that it requires trust. Not the same kind of trust as like you would have with a custodian. However, there is trust involved The main advantages, I think, are, which maybe we're going to discuss the subtleties of, that there is a type of, it's non-custodial. There's been kind of arguments about whether it is really non-custodial. Ruben came up with this nice description called, I'd say, like preemptively non-custodial. And censorship resistant. So in principle, the whole idea of it, well, the whole advantage is that even if using a money on a state chain, so using a state chain entity or this trusted party, that your money can never be seized or frozen. And in order for the state chain entity to steal from you, they would have to kind of plan an attack in advance and a fraud in advance. So really the two real advantages over a fully custodial solution is the fact that, your funds can't be frozen or seized. And also that the state chain entity can't arbitrarily decide to steal from you. But I guess, I'll go into exactly where the trust is. But so it's essentially, so on a kind of lower level, exactly what happens is that someone will deposit Bitcoin into a state chain, or we call it, the state chain entity is the operator of the state chain who must be trusted. And in Ruben's original design, this goes into a 2 of 2 multi-sig. And that one key belongs to the state chain entity and the other key belongs to the depositor. And in Ruben's original concept, you'd use some kind of secure way of transferring the key using like adapter signatures. But essentially what would happen is that then the owner would then transfer ownership of that UTXO to a new person. They would just hand over the key to the new owner. And then the state chain entity is basically going to promise only to cooperate with the new owner to co-sign the transaction. But in addition to this, the first owner and the new owner, the state chain entity will co-sign like what's called a backup transaction, which enables the current owner and only the current owner to redeem the Bitcoin if the state chain entity disappears and or doesn't cooperate.
Is that similar to Green Wallet?
Yes, in a way, yeah. But the issue with state chain is obviously you need to, just like in Lightning, when the new owner's backup transaction has to supersede the previous owner's backup transaction and has to become valid. And so there's in Ruben's original idea, the plan was to use like L2 based kind of update mechanisms. So the new owner would get a transaction which could always claim the output. If a previous owner tried to submit an invalid state, just like in Lightning, then the true owner has a transaction which can then take the output. So they need to kind of watch the chain and make sure that the previous owner doesn't submit an expired backup transaction. So we don't have L2 at the moment, and we may not for a long time. And I think it's I think it's a dangerous game to play, to wait for these kind of protocol upgrades.
Yes, because L2, for you freaks, you don't understand, we're not saying L2 like the letter L2, layer 2. We're saying L2, ELTOO. This is something that many second layer solutions have been waiting for, but it requires a change at the protocol level, correct?
Yeah, this is kind of the sig hash no input, so it's basically new sig hash type. So but there are alternatives to this, and one of them is to use like time locks, incrementing time locks, so that you can essentially say the new owner basically can use their backup transaction earlier than the previous owner. So this does have some, unfortunately, I mean, with L2, you could essentially have kind of billions and billions of updates. But with the kind of a time lock based solution, you do limit the kind of number of transfers you can have, and also the amount of time people are going to have to wait in a kind of a backup situation, which is it should be clear that the backup situation is kind of only if everything goes wrong, the state chain entity is shut down or blown up. So using this kind of decrementing time lock solution, in addition, we have a slightly different approach to Ruben's original specification is that we have this key recycling mechanism, which increases the security, but relies upon this multi-party computation way of doing basically a 2 of 2 signing. So instead of using a 2 of 2 multi-sig, we have a single split between the state chain. Exactly what
I'm here. I just shut my video off.
This is exactly what Chris Belcher is doing for his CoinSwap implementation. So I mean, we have to use this 2-party ECDSA because of our key update mechanism, but it does have other really great advantages in that you have a much bigger anonymity set. You have a smaller on-chain kind of transaction size, which saves in fees. And that to anyone, on the blockchain, it just looks like any other single, to pay to public key hash output. So a bit about this key update mechanism, which gives one of the crucial properties of the fact that it makes the whole thing kind of hack proof. So what happens is that when someone deposits funds onto the state chain, they generate a shared public key, shared two private key shares, but shared public key. Money's paid to that. Bitcoin's paid to that public key, and then when the ownership is transferred to a new owner, what happens is that the new owner generates their own private key, and then we do a multi-party computation between the state chain entity, the old owner, and the new owner, and we actually update the private key of the state chain entity such that it now can only be used to sign the UTXO with the new owner. And so long as the state chain entity deletes the previous private key share, then the old owner, there's no way that the old owner can co-sign to spend the Bitcoin.
How could you prove that you're deleting those keys?
Well, this is the key thing. So where there's an element of trust. So if the state chain entity does what it claims to do and actually deletes that key, so you're trusting them to delete that key. If they delete that key, then the thing is completely secure. And an old owner can never collude with a state chain entity to steal money. Also, obviously, the state chain entity can't be hacked by an old owner to steal the money because the key is gone. But that's the critical thing, is that you need to trust the state chain entity to actually delete that key for the whole thing to be secure. So there's several ways you can go about that. I mean, essentially, it is always going to be, to a certain extent, reliant on some kind of trust. What we're currently implementing a kind of hardware trusted execution environment solution where we use a trusted enclave that's capable of doing like remote attestation. I don't know if you know, like Intel SGX, which enables you to basically obviously you're kind of preventing kind of people, so hackers who had like physical access to the machine, or from basically watching the system and had root access and could kind of record old key shares. Also, you can do some remote attestation, so you can actually prove to given the assumptions of the trusted hardware, that you're actually performing the deletion that you claim to be.
But it's an unsolvable aspect of the implementation, and that's fine. It just is what it is, right? Because like you could always be the old owner, and if you're the old owner,
exactly,
right, then that whole you have to trust the coordinator no matter what.
Yeah. You have to, and there's things you can obviously. That's what it's going to boil down to is the trust and the reputation of the coordinator. So there are other options. Is further splitting the key and becoming more of a federation, so that then you can say split the key, say of the state chain entity 3 ways, and maybe have 3 different kind of organizations. And if any one of those deletes the key, then the whole thing is secure. But yeah, but fundamentally, yeah, it is, you are trusting the state chain entity to delete the key.
Yes. But I'm a big fan of economic incentives, basically disincentivizing any collusion from a state chain entity or coordinator.
Yeah.
Moving against their clients. So what are the economic incentives for you guys not to collude? I guess?
So I think that this whole thing doesn't protect you against a malicious state chain entity. A malicious state chain entity could decide to conduct a fraud against a user and steal from them. But an honest state chain entity who is hacked, who has been operating honestly, or a state chain entity who is, say, taken over by the authorities or subpoenaed or something, has no power to actually seize funds, unlike, say, a custodian. So yeah, that's the fundamental kind of trust trade-off. But another feature that we've added is, well, it's the state chain itself. I mean, it's called a state chain because you actually have a chain of signatures which determines ownership of the UTXO, and that this actually is a proof of your ownership. And so any user who's stolen from has evidence that they've been stolen from. So that, yeah, you essentially have a proof of fraud. And that this proof of ownership is kind of attested to Bitcoin, so that you have this kind of proof that nothing's been double spent, everything is uniquely owned. And then you're relying upon the state entity being trustworthy. But in a way, I think as a business, that there is some virtue in that, because the trust element enables you to create a brand and a reputation. I think the problem with, well, from a business point of view, the problem with completely trustless kind of protocols is that there's no money to be made from a business point of view, because there's no requirement for any kind of reputation. So yeah, you can always kind of, it's a race to the bottom if you're providing kind of, completely trustless services, because obviously anybody can do it. Anybody can be anonymous and do that. So yeah. So I guess that's an overview of the basic underlying kind of mechanism by how this works. But then, yeah, I can go on to talk if you want about the kind of privacy applications we're thinking about and doing essentially off-chain coin swaps.
Yes.
So
I want to jump more into that, and then because I want to jump into that and how limited is the scope of the applications of a state chain layer due to the fact that you need equal size UTXOs.
Yeah, so the equal size UTXOs thing is, I guess, a big problem for some applications. So, I mean, I really like the idea of doing some kind of, you could do some kind of, non-custodial, proactively non-custodial exchange. But the thing that the fixed size UTXOs hampers there is the fact that, yeah, you can't really make up arbitrary amounts. So I guess using it for payments is an issue, because you can have a wallet with, say, certain fixed amounts, just like you do, you pay for you pay with cash. I mean, you can obviously, you you have certain fixed denomination notes or coins, and in a transaction you can obviously receive some other change, and there's ways to do this that you can kind of minimize the number of coins you need. So that is one limitation, but I think if with the right kind of user interface, this can be kind of overcome quite easily if people don't have to do that kind of coin selection, manually, and if the swapping, the change swapping is kind of made kind of seamless. So fixed amounts though can help for kind of privacy applications. So doing coin swaps. So obviously choosing certain fixed amounts, you can maximize the number of potential, the anonymity set and the number of potential other people you can swap coins with. The service that we're planning to kind of when we have our full implementation is essentially a coin swapping service. So this essentially would mean users come along with a fixed denomination UTXO, so 0.1 Bitcoin, say, and then join basically register that coin with a swapping service, like a coordinator, and then that this would be swapped with other users' coins. So what we've done is we've implemented a scheme to do this, which is kind of quite similar to the zero link protocol that, say, Wasabi uses to blind the basically the swap matching from the coordinator itself. So I mean, so it's doing these kind of off-chain coin swaps. I guess you're getting two layers of privacy. One is privacy from the blockchain itself, so that you're not publishing the swap on chain, and so that the on chain transaction graph is not telling you who's swapped with who. But then the coordinator itself obviously can record information about which coin has swapped with which coin. However, with this protocol, which is a bit like the zero link protocol, using blinded signatures, essentially, if you have a group of, say, users, say there's 4 of them, they each register that they want to swap 0.1 Bitcoin coin for someone else's 0.1 Bitcoin coin. This coordinator essentially takes those 4 coins and then randomly assigns each one of those coins to another random individual in the group. And then with a blinded token and using a new Tor connection, you then are able to basically receive a coin, a new coin, which wasn't yours. And although you know which coin you swapped it with, the coordinator doesn't know who swapped with who. So the real aim with this is that we're hoping to make this kind of very quick and easy. So it's like I said, it's a trade-off between, obviously you have to trust the station entity and this coordinator, although they never have custody of your funds. But this can happen very quickly. These are kind of almost instant transactions. So that we're hoping that this will enable much higher kind of frequency of swaps, so people can kind of join the system and then do these very, very fast rounds of swaps with lots of individuals, and then when they're ready, go back on chain, and that we've removed a lot of that transaction graph information away from the chain and hidden it from the coordinator as well.
So, I mean, the key here is that you need to do multiple swaps so that you don't have to trust the person you're swapping with, because they know what their previous swap was, right? So what's the fee structure? What's the planned fee structure here? How does that work?
So yeah, I mean, we thought about this, and the trouble is, it's almost impossible to charge a fee for swaps or transfers because of this fixed amount restriction, this fixed UTXO. So we think the best way of doing it is just charging a fee, say, on withdrawal. So then that fee, entry and withdrawal. The issue we had with thinking about charging the fee on deposit was just from a user experience point of view, is that if you're going to pay in from a third-party wallet, you would have to explicitly include a fee payment as well, which may be an issue.
Well, you could do it the way Whirlpool did it, right? Where the only way to come in is through your wallet, through Mercury Wallet.
Yeah. When that's one thing that we can add. We originally were going to make the wallet kind of both a Bitcoin and state chain wallet. So you'd have a Bitcoin balance and a Statecoin balance, and you could transfer between the two.
And that's where the fee would get taken in my mind. So how does the fee get taken on the withdrawal side? How does that look?
So you basically would have to do to withdraw, you have to get the state chain entity to co-sign, and the state chain entity would just say, I'm only going to co-sign if this withdrawal transaction contains an output paying me, the fee. But then within the state chain, every transfer would be then feeless and free. So
that's awesome. So swaps would be infinite swaps for free, for no additional cost.
Yeah, I mean, obviously that's kind of you could think that potentially is a DOS risk, because people can just spam. But the thing is with the time locking of the backup transactions is that you only have a finite amount of swaps you can do. So you can do like 500 swaps. So obviously people, I think will be incentivized not to run down that number, because otherwise then the closer you get to that number, you then are going to have to do a withdrawal and an on-chain transaction. So
yeah, and having entry for the state chain be through the Mercury wallet makes a lot of sense. You see Blockstream coming out with Aqua, that new wallet that allows people to go between on-chain and liquid pretty easily. It seems like that's becoming a more, or I don't want to say standard, but the precedent's being set for that type of interaction with the second layer, just to be baked into wallet software inherently. The infinite rounds with no added fees seems like a huge improvement. So what I'm trying to get at here is like, how does this compare to CoinJoin specifically, and is it like an inherent upgrade? Matt, I assume what your answer will be is that you use both or a combination of the two, but I think just like from a cost of attaining a sufficient privacy perspective, like how competitive is this with a CoinJoin implementation like Wasabi or Samurai?
Well, I mean, I was going to say, before Tom jumps in here, I mean, the way, because I think it seems like really dense topic, but from like a high level point of view, the way I'm looking at it right now is this is basically zero link, which is what we see for Whirlpool. That's what Whirlpool and Wasabi is based off of, with slight differences. This seems closer to Whirlpool's model in terms of like the fee structure and the incentives. I think it's, all else equal, it seems like a privacy improvement in terms of effectiveness with additional trust. You add trust to the system to accomplish that improvement in privacy, and that trust being, if the coordinator wants to be malicious, they can take your funds. If a malicious coordinator in traditional zero link schemes can't take your funds. They can just degrade your privacy.
Yeah, that's right. Yeah. So I guess it's about that trade-off. I mean, I guess it sits somewhere between a fully centralized mixer and the Whirlpool Wasabi coin joins where, you always retain full custody. Always, no one can steal your money in those protocols. So it's a trade-off that you get this potentially increased kind of anonymity set. But you're not giving your money directly to a custodian like you do with a centralized mixer. So it sits somewhere. I'd say it sits somewhere in between those.
And the beauty there is historically, even though a custodial mixer provides great on-chain privacy, if you can trust the custodian, they've been a massive regulatory target. So I think what Ruben has been saying is legal custodialship, which is this idea that if you're acting in good faith, a regulator shouldn't consider you a custodian because you can't take funds or seize funds in that situation. Which is a massive improvement in terms of regulatory protection. And then I just wanted to say, in terms of, I really like the idea that you basically leaned into this issue with Statechains, that it's single denomination. Because on privacy, that's desirable. You don't really have a choice anyway. That's not even a Statechain limitation there.
So you're kind of, if you're just if people kind of standardize the value of the coins they use, and you massively increase the privacy for all of those. If suddenly, you've got thousands and thousands of 0.01 Bitcoin UTXOs, that does, just increase a lot. The ability of, the ability of people to kind of mix and swap. But you're right about the regulatory thing. I mean, that's a big thing for a business as well, that you, I mean, it's a bit of a regulatory hack, really, to do this, that you're running a centralized, trusted service, but no one can come and say to you, please seize this. It's non-custodial because we haven't recorded these keys. We haven't colluded them with anyone. Therefore, we're completely powerless.
Yeah, and you can't move the coins by yourself unless you're the counterparty in the Statechain transaction as well. This is fascinating. And again, this is something that's Ruben wrote about it last year. We've been talking about it, but not until your announcement a week or two ago that you were launching Mercury Wallet on testnet, on Bitcoin's testnet. Like, I haven't heard anybody even attempting to create an implementation. So I'm just extremely excited that I'm sure you guys have been vocal about it for a while, and I just missed it. But
well, we started kind of working on it, I guess, back in kind of April, May this year. So the first step is obviously to get it all working properly, kind of protocol-wise, command line-wise. And so the current, when we say Mercury Wallet, at the moment, it's a very simple kind of command line client. But we're now working on the full kind of final GUI wallet, which hopefully will be ready in a month or two.
Awesome. How's the reception on testnet been? How has the software been? Everything's working. I don't know if many people have actually tested it. I mean, it's quite technically involved. If the way we should probably do another launch with maybe an easier to use client. At the moment, anybody would have to download the Rust and compile the Rust themselves. So a few people tried it though. If any of you Rust devs who listen to this podcast are out there, get on it. I'd love to see this tested out. And so what are the plans? So you want to have a GUI within a month, hopefully.
Yeah.
Where do we go from there? Is there something or an amount of data you're looking to observe on testnet before you guys launch a mainnet product? Or
we'll keep doing testing, and we want, it's a new thing. I mean, I guess we'll kind of do like a soft launch where we would tell people to maybe not put serious amounts of money in it to start with, a bit like when Lightning was launched. Don't Be Reckless, essentially build up confidence, make sure, because it's a new protocol, it's a new model. We need to make sure it's very robust and secure. And yeah, hopefully this will basically start happening kind of over into the new year. Moving on to other kind of applications is very interesting as well. And we still have this discrete log contract use case in mind, and so it'd be that'd be a really cool thing to do as well.
Yeah, we're big fans of DLCs here.
Yeah, that's kind of it. There seems a lot of promise there to create, to create kind of derivatives that can be traded. I think could be very powerful. You have like synthetic dollars and things. It can be.
Yes. So you're working on all this very interesting tech. I'm interested to learn more about you, the person, Tom. Like, are you interested in this stuff because of the tech, the liberating nature of the technology? And do you like the sound money aspect?
Originally I was drawn to the technology, and then I think there's something about this. I know quite a lot of people who studied physics are really into Bitcoin. There's something very alluring about this kind of a proof of work, and the fact that you have this this global state, which is kind of there's an objectivity to it, which is very very fascinating, that you have this single global state, which is completely kind of no one can control it, and that you have this huge amount of energy that goes into securing it. It's a really, really fascinating kind of machine when you kind of look at it. And so I think that was originally the big draw for me. I mean, I've always really been into cryptography as kind of a hobby, and really fascinated by kind of modern cryptography and all the magical things it can do, zero knowledge proofs and all this kind of stuff. But yeah, the more I've got into Bitcoin, the more kind of convinced I've become about how kind of revolutionary it is going to be, in terms of kind of undermining all kinds of established kind of power structures. And it's really weird that when you try and explain it to people can't even. It's difficult to even communicate to people that you have this thing that basically is incorrect. No one can control this. No one can corrupt this. And so that's I think is its biggest kind of appeal, is this way of storing value, transacting value that is impossible for anybody to stop or these. And the more kind of you start to think about the consequences of how this is going to change the world. And I don't know the answer to that. I don't, and I'm not sure about kind of hyper Bitcoinization and all these things, but I think it's going to be a big deal in the future.
I actually recently reread Misha Trubisky's piece on proof of work, essentially just being a decentralized clock, like you mentioned, proof of work creating just a state at any given point in time of the ledger. And it's crazy to think. So I originally came to Bitcoin fascinated by the sound monetary properties and its effect on economics and finance. But as I get further down the rabbit hole, I just become more drawn and more focused on the proof of work aspect, just turning energy into these hashes that could potentially produce Bitcoin. And it's fascinating when you have the aha moment over proof of work of how it really melds the physical and digital worlds together in a way that's never been done before.
Yeah, I mean, it's this kind of like what's called like thermodynamic immutability. It's that you have this way of now you have this kind of source of truth now, which didn't exist before. Nothing like it has existed before. the consequences of this is difficult to really predict.
Yeah, and it's funny watching people, particularly in the altcoin world, sort of gloss over proof of work and run right to what I would argue are untested
fundamental misunderstandings, and you see a lot. I think people have been involved in these kind of like kind of Byzantine fault tolerance protocols and things. I think there's a misunderstanding that proof of work is just a kind of a way of nodes to agree, but it's a lot more than that. That has so many kind of specific properties, and I think it's the only real kind of permissionless way to have any kind of consensus. But yeah, it's kind of it's a really incredible thing that you have this. It's basically impossible. No, it doesn't matter who colludes. It doesn't matter who kind of the subjective opinions of the rest of the world. There's this one objective source of truth that anybody can independently verify. It's kind of I think there's so many unexplored use cases for this as well. For proving things. In a trustless way.
No, I love having conversations with physicists on this podcast. Dhruv Bansal being one of my favorite, because he just naturally takes it to the nth degree, talking about Bitcoin in space and how this can help us interact with intergalactic communities if they exist, and Dyson spheres. And if you try to play this out, if it's successful, like, will Bitcoin mining eat up all the energy in our solar system?
But it might eat up all the spare energy,
Right.
But and that's I guess another thing that people that kind of is slightly annoying about criticisms of Bitcoin's energy use is again a failure to understand what it is actually achieving, and that the energy isn't wasted. This is replacing trust essentially, and trust is usually very, very energy inefficient in the real world.
People don't know how to calculate and define the opportunity cost of not using that wasted energy to produce Bitcoins. It's it's a learning process. It's a huge learning curve too. Coming to these, like, wrapping your head around proof of work, wrapping your head around money to begin with, and then everything you can do with an UTXO. So that's one thing. I have a theory that you could apply Jevons paradox to a Bitcoin UTXO, and seeing you create a state chain implementation sort of feeds into the narrative behind that theory, which is, if you can make UTXOs more useful, give them more utility, they will be used more, and therefore driving a sufficient fee market to sustain mining with a hard supply cap into the future.
I can kind of can see where that's going.
So why Mercury Wallet? What's any reason behind the name? Have anything to do with?
I don't know if it came from. I can't remember the exact reasoning for it. It just sounded good. I think we'd used a Mercury name before for some kind of element stroke liquid kind of thing. But I can't remember the exact name. But I think it's one of these things that just stuck. Seems to sound quite nice. So
again, thank you for putting in the work to get this implementation to market. It's, again, something we've been talking about. I know it's only on testnet now, but the fact that somebody's working on it is incredibly bullish in my mind.
Yeah, it's been a lot of fun. It's been a really fascinating thing to work on. And again, it's my first kind of use of Rust in kind of in something real. So that's been quite interesting, and challenging. But it's been a lot of it's been very interesting and a lot of fun to to build this. And everyone's very enthusiastic about it on the team. So yeah, and it's one of these things. Yeah, I just got a good feeling about it. I think it might, be in the right place at the right time, hopefully be useful.
I mean, if it helps with privacy, I think it will certainly be useful. We think that's one of the most needed areas of improvement in the Bitcoin stack is privacy tools. So
yeah,
another option is just incredible.
I just wanted to jump in here real quick. First of all, appreciate the work. I've been we've been very focused on privacy here for a while now, and we think it is one of Bitcoin's major, UX issues, mostly in terms of directly right in the face of user. And I think it's a major vulnerability too, mostly on the user side. The number one thing for all these systems is the amount of people we get using them. So
exactly.
do not diminish, do not underestimate the importance of UX here. Like it needs to be straightforward for the user, where they can conceptualize it, and there can't be that many foot gun things, because if there's a way for the user to shoot themselves in their foot, they probably will. And with these systems, it usually hurts other people's privacy as well, because it diminishes the overall the overall anonymity set. I have a question. Has there been any thought into using this type of implementation as like a private way to do like swaps between Lightning and Liquid and on-chain?
Well, I guess there's two. There's been lots of people have mentioned doing using this on kind of Lightning channels, being able to swap ownership of Lightning channels in the same way that you swap ownership of a position in DLC.
Right.
But yeah, the you could do swaps. Again, our current model is that you basically trust the coordinator to do the swap atomically. But there's no reason you couldn't swap anything.
Like I feel like specifically with Liquid, it'd be like really easy to implement into something like this. Am I mistaken there?
To do a kind of an LBTC BTC swap.
Where like the people who enter the state chain for the swapping of this in the state chain could be either Liquid or on chain, and they could come out either Liquid or on chain. That's an interesting idea, actually. Which would be easy, because obviously it's the same. Obviously swapping with a different currency is, you have the problem of the fixed amounts. But I guess on this would be exactly the same. It's already pegged anyway.
Yeah, that's quite an interesting idea. Like people would, I guess, like that because there's more privacy.
Yeah, because it'd be interesting that you could come in or out with Liquid or on chain. It would make an interesting privacy heuristic breaker there.
Yeah, that's an interesting idea.
And it's the major shortfall of Liquid right now, is coming in and out.
Yeah, because to do a peg out is
so it could benefit both,
Yeah.
Matt with the hot product tips here on TFTC. Tom, I know we have a hard stop because you have to pick up your children. Is there anything we should wrap up with, particularly that's on your mind? Anything to focus on? Anything?
I don't think so. In particular, hopefully I've been able to, get across everything we're doing. But yeah, I mean, if it would be great if people would want to, help us test it out. Also, everything we do is completely open source. And yeah, I mean, if people wanted to go ahead and set up their own state chain entities, they're kind of, welcome to do that. And yeah, basically we appreciate any kind of feedback people can give us. But it's been, we're getting a lot of good, kind of feedback on, that this is something that people would use and people would find valuable.
Oh yeah. No, I think I'm very excited to see a proper implementation of Statechains come to market. And it seems like you guys are on the right path, and very much looking forward to the GUI and the mainnet product when it launches. I'm sure we'll definitely be testing it out and letting the freaks know how it went. So definitely keep us updated on everything that's going on.
Yeah, sure.
Matt, do you have anything to wrap up with?
Thanks for coming on, Tom. Really appreciated this conversation.
Yeah, no, thanks for having me. It's been good.
I appreciate it. Well, I hope you enjoy the rest of your night.
Yeah.
Thank you again for taking an hour to come explain this to us. Again, very bullish and excited to see what we have in store moving forward. So
cheers.
That's all we got this week, freaks. Cheers.
Cool. Cheers.
Peace and love. Tiki.